we have to start our topic vectors. This is the topic 7 of your paper 3 of A2 or A levels paper 3 topic 7 vectors. In this topic, we will discuss about specifically the vector equation of the line in 3 dimension. Also, we will discuss that how to determine where the lines are parallel, whether they are intersect or they are skew lines. Also, we will find the point of intersection of two lines. We will see here that what are the scalar products and how can we use scalar products in our problems which involve some lines and points. So let's start with the topic. Vector equation of a straight line in 3 dimension. We want to find a vector equation of a straight line. But before this, let's talk something about the 2 dimension. In 2 dimension, we have a straight line and we call it y is equal to mx plus c. Let's consider here the straight line we have y is equal to 3x plus 2. In this straight line, x is a variable here. So it means that when I will change the value of x, the value of y will change because x is an independent variable here, y is a dependent variable here. If I will change the value of x here, I will get some new value of y. So let's suppose if I place here x0. If I place x0 here, what will be the value of y? Y will be 2. Let's see what will be in the graph. Yes, so this is our initial point. And what is this point? This point is 0, 2. Now, if I place the value of x as 1, so I got a new point, 1, 5. If I place a value 2 here, I got a new point 2, 8, and we form a line. So that's why we say that 3x plus 2 is an equation of our straight line. Now, what we are interested in, we want to find the vector equation of a straight line in 3 dimension. So let's suppose that if I assume an equation r is equal to 3, 0 minus 2 plus lambda times 1, 1, 0, that is very similar to this equation. You can see here there are quite few similarities here, that y here is a subject r here, we have a 2 constant here, we have a constant vector here 3, 0 minus 2, we have a constant number 3 here, and we have a constant vector here 1, 1, 0. Here x was the variable, we have this lambda as a variable. So let's see what happens. Now the same technique if I use here, if I place the value of lambda 0, so what should I get? This will be 0, so I should get a point 3, 0 minus 2. Let's see. Yes, I got this point 3, 0 minus 2. If I change the value of lambda 1, so if I place here 1 instead of lambda, what will I get? 3, 0 minus 2 plus 1 times 1, 1, 1, 0, and I will get new point 4, 1, and minus 2. And if I plot this point on a graph, what should I get? Oh, yes. So again, this is forming a straight line. Let's check another point. If I place lambda 2 here, I got this one. And if I take some negative value of lambda, I got this one. So again, I am forming a straight line. So it means we can say that r is equal to some constant vector plus lambda times some constant vector will also give us an equation of a straight line. Now there are few things important that you have to remember here. The first thing, what is the role of 2 here? This 2 was here your y-intercept. This was your y-intercept, or you can say this was your initial point. Okay. Now the same role is here of 3, 0 minus 2. So this 3, 0 minus 2, this point is our initial vector, or you can say this is our starting vector, or we can say that this is our position vector from where the line is starting. Okay. And what about this 3? This what is the role of 3 here in this equation? This 3 was a gradient. Yes. You can see here, if I find the gradient here, what is the change in x here? From 1 till 2, there is a change of 1. What is the change of y here? From 5 to 8, change of 3. So gradient is 3 upon 1. So we have a gradient 3. And what is the role of gradient? That it gives the direction of the line. Yes, the same role is here of this vector 110. So this 110 vector, we call it a direction vector. Now remember two things. This vector with a constant vector without some variable, this is your initial vector. This is your initial vector, starting vector, position vector. And this vector with the variable lambda here, this is called as a direction vector. Okay. So this 30 minus 2 is the position vector of some arbitrary point, and 110 is the direction of the line, or we call it a direction vector. So now we can say that the vector equation of a straight line, and we call it R here. So R equals to A plus lambda times B. The very similar to Y is equal to mx plus C. Okay. Here the subject was Y. Here we use the subject R. Here we use the variable X. Here we use the variable lambda. Okay. And the rest things are same, where A is the position vector and B is your direction vector. Here there are few things that you have to understand and you have to remember. The first thing, that A and B both are constant here. It is very useful that if we write this equation of the line in this form, you will see that when we solve vector question, it will be quite helpful for us. So instead of writing the whole equation in this form, we can make benefit of our matrix theory, that we can add them and we can write like this in a column vector form. It will be quite helpful for us. And the last thing, that you should distinguish that what is the position vector and what is the direction vector. Here this A is your position vector, while this B is your direction vector. This is your position vector. This is your direction vector. Okay. In this case, what is the position vector? 30 minus 2, or you call it initial vector, starting point. And what is this 110? This is our direction vector. Okay, let's see some question. The equation of the line L1 is R equals to 30 minus 2 plus lambda times 110. Find the vector equation of a line parallel to L1 which passes through the point 251. Now, what we want? We have some equation of the line. We have this line and they call it L1. We have this line. We want a vector equation of another line which is parallel to L1. So it means this line we have another line that is parallel to this line. When two lines are parallel, their gradients are same. Yes, but here we do not use the word gradient. We say their direction vectors are same. What is the direction vector of this equation? 110. So it means the direction vector of this equation is 110. So direction vector of this equation will also be 110. Now, what we have seen in the previous slide, that we have the equation R is equal to A plus lambda times B, where what is B? Direction vector. So it means we have a direction vector 110. Now what is A? A is your position vector. Now you can see here which passes through the point 251. So 251 is your position vector. So I can write here 251. So this will be my equation of another line. Okay. Now see some one more example here. The equation of the line L1 is R is equal to minus 103 plus lambda times 110. Find the coordinates of the points on L1 which is a distance 3 away from 344. We have again equation of the line this L1 here. Find the coordinates of the point on L1. There is some point and we want to find the coordinates of this point, which is 3 units away from another point 344. This point 344. Now we want to solve this. The first thing is that what we do, we make we construct a generic point on this line because we don't have anything here given. We have just one point here, that this is 344, and this is the line of the equation, and the distance from this point and this point is 3 units. Now we have only 1.344. We have this equation of the line. Now what can I do? If I write this equation in this form, minus 1 plus lambda 1 times lambda, 0 plus lambda, and 3 plus lambda times 0 will be 3. So I have generated a generic point. A generic point means an arbitrary point, a general point. And what is this point? Minus 1 plus lambda, and 3. Now I know that the distance between these 2 points is 3. Now you know from your AS that what is the distance formula. So the distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square if we are working in 3 dimensions. So we have these 2 points here. This is suppose x1, y1 and z1 here. This is x2, y2 and z2 here. So I can use this formula here and I can find the distance. So what I have calculated here, that is equal to 3. So by solving this, I got this equation lambda square minus 8 lambda plus 12 is equal to 0. This is a quadratic equation. I can solve this equation and I find 2 points, 2 and 6. So if I place the value of lambda 2 here in this equation, what I got this point 1, 2 and 3. And if I place this 6 here, what I got the another point 5, 6, 3. So these are the 2 possible points that are at a distance of 3 from 3, 4 and 4. And it looks sensible because we are talking about that we have 1.3444 and the another point is 3 unit away. We just know that it is 3 units away. So it can be 3 units away here. It can be 3 units away here. So we have 2 possibilities, 1, 2, 3 and this another 5, 6, 3. See some more examples. Find a vector equation of the straight line which passes through the point A with position vector 3, minus 5, 4 and is parallel to the vector 7i minus 3k. Now, what we want a vector equation of the straight line. Suppose this we have a straight line here. It passes through the point A. This straight line passes through some point A here with position vector 3i minus 5j plus 4k position vector. So position vector was initial vector and is parallel to 7i minus 3k. So it means there is another line that is 7i minus 3k. So how can I write this 7i minus 3k? I can write as 7i 0j and minus 3. So this is my direction vector. Since they both are parallel, so for this line, we have a same direction vector 7, 0 and minus 3. So what we got, that our initial point was 3, minus 5, 4 and our direction vector was 7, minus 3. So what will be the equation of our line? That will be, this is our initial line 3, minus 5, 4, r is equal to a plus lambda times b plus lambda times 7, 0 and minus 3. So this is my vector equation of this line. Okay. See one more example. Find a vector equation of the straight line which passes through the points A and B. Now we have a straight line which passes through 2 points A and B. One point is A, another point is B. And we have the coordinates given, that 4, 5, minus 1 and 6, 3, 2. You know that we can always write our coordinate as a position vector. So if I have a coordinate A 4, 5, minus 1, then I can say that I have a position vector 4, 5 and -1. Now to find the equation, what we need only two things. The first, the initial position vector, and the second thing is the direction vector. Now how can I find the direction vector? This is the line passes through A and B. If I subtract these two, then should I get the direction vector? Yes. So if I subtract these two, so I have subtracted these 2 points. So what I got? We got a direction vector. So our direction vector is 6 minus 4 is 2, 3 minus 5 is -2, and 2 minus -1 is 3. So we have this direction vector. Now you can easily find the equation of the straight line. So if I take this starting point, so our equation of the line will be 4, 5, -1 plus lambda times 2, -2 and 3. So this is one possible equation. And if I take this as an initial point, so now our second equation may be 6, 3, 2 plus lambda times 2, -2 and 3. So these are the two possible equations of this straight line. Okay. Now, some more examples. The straight line has a vector equation r is equal to 3i plus 2j minus 5k plus t times I minus 6j minus 2k. So this is the equation of a straight line that is given to us. Given that the point AB0 lies on line L, we have this line L here. Our equation is r is equal to, I can write like this, 3, 2 minus 5 plus t times 1 minus 6 and -2, and it passes through the point AB0. We have this point AB0. Find the value of A and find the value of B. Now think, how can we find the value of A and B? Since it is passing through the line, this point is passing through this line, so this point must satisfy this equation. So if I make a generic point, that is 3 plus t, 2 minus 6t and -5 minus 2t. So it means this equation of a line must satisfy this point. So it means I can equate them, that is equal to a, b and 0. And when I will solve these two, we can make a simultaneous equation, that the first equation will be this. Our first equation will be this one, -5 minus 2t equals to 0. Okay, so that will be our first equation. This one equals to 0. So I got the value of t here, and when I place the value of t here, I will get the value of b, and similarly when I place this value of t here, I will get the value of a. One more example. The straight line L has a vector equation r is equal to 2i plus 5j minus 3k plus lambda times 6i minus 2j plus 4k. Show that the vector equation of the line L is this. R is equal to this one and this one. Another vector equation. The straight line is same. We have the same line L. The question says that the one possible equation is 2, 5 minus 3 plus lambda times 6 minus 2 and 4. And the other possible equation is this one. Now, how can we do that? The first thing, because these two equations are the equations of the same straight line, so it means they both must be equal because they are of the same line. So what we do here, that we can equate them. Okay, we can equate them. So our first equation will be, that will be 2 plus 6 lambda, then 5 minus 2 lambda, and -3 plus 4 lambda. So I got this one in this form. Now this equation will convert into 8 plus 3 times mu and 3 minus mu and 1 plus 2 times mu. Now you can equate them, you can find the value of lambda and mu, and you can check that whether they are same or not. The other way is that we are saying this is the one possible way. The other way is that when two equations are of the same line, so it is necessary that they must have the same direction vector. Now look at the direction vector of this line, 6 minus 2 4. What is the direction vector of this line? 3 minus 1 2. So you can see here that is 6 minus 2 4. If I take common, or you can say that 3 minus 1 2 is 2 times of this 6 minus 2 4. It is a multiple of this. So it is a multiple of that, it means they have the same direction. Or you can say that when the lines are parallel, their direction vectors are same. And what are the direction vector? Direction vector are the simplest vector. So this vector is 6 minus 2 4, and if I take some common, I get the same vector here, 3 minus 1 2. So these lines are parallel here. Now what can I do? The first thing is clear that they both have the same direction. Now if I take some arbitrary value of lambda, I place some lambda value here, so that is 2 5 minus 3. So I got a point, this r is equal to 2 5 minus 3. Now the same point I can find from this equation as well. If I place here mu negative 2, okay, so I will get the same point here. So direction is same, initial vector is same, so it means these two equations are the same. So there are two possible ways to solve this one. The first possible way, you just equate them, okay, you just equate them, find the value of lambda and mu, and just place this value of lambda and mu here, and you will get the same point. The other way, they both have the direction same, and if I place some lambda here, what the point I get? The same point can I get from the second equation as well. Now we have a topic of scalar product. You have covered this topic in your AS, so I will just give you a recap of that. What is the A dot B? Scalar product, we also call it a dot product. It is a sum of all A and B, or the products of A and B. For example, if we have these two vectors here, this is a vector A here, this is a vector B here, then what is the dot product? 3 times 4, that is 12, 2 times 0, 0, 1 times 1, 1, and then just add them. So what you got? 13. So the dot product is sum of products of their x, y, and z. So this is the x of both, this is the y of both, this is the z of both, right? Now see one more example. This is 5 3 is 15 minus 6 plus 0. 15 minus 6, 9 plus 0, you get 9. If you have this one, you can say this is 3a plus 5 times b plus 10 times 1, 10. So this is the scalar product. Now, why we use the scalar product? Scalar product we use to find the angle between two vectors. So if we have two vectors and then the dot product of their unit vectors will equal to the cos theta, or in other words we say that cos theta equals to A dot B divided by their magnitudes, okay, or you can say like this, the unit vector of A and unit vector of B and the dot product of both unit vector will give you cos theta, right? You know about the unit vector. What is the unit vector? The vector divided by its magnitude. Now look at this one, the find the acute angle between the vector A and B. We have two vectors and we want to find the angle between them. The first vector is 5 3 1. So what we do here, simply we find first their dot product. So what is the dot product of these two? 5 3 1 and 1 0 5 here. So dot product will be 5 plus 0 plus 5. So that will be 10. So our dot product is 10 here. Okay, now what is the magnitude of this A? What is magnitude? Just take squares of and then add 5 square plus 3 square plus 1 square. So that will be 25 plus 9 34 plus 1 35. And what is the magnitude here? 1 square plus 0 square plus 5 square. So that will be square root of 26. So these are the magnitudes. This is the dot product. So cos theta will be A dot B, that is 10 divided by square root of 35 times square root of 26, and you can use your calculator to find the angle, and that will be cos inverse 70.64. So this is the angle between two vectors. Now there is one important thing when you find the angle between two vectors, that is that whenever you are going to find the angle between two vectors, okay, you must ensure that the both vector must be away from the point. Away from the point. Remember this thing. For example, if you see this first example, that this is the vector A and this is the vector B. The direction of vector is this and direction of B is this. They are not away from their point. One is away from the point, the other is towards the point. So if you will find the dot product of A and B, you will not get this 30 as the correct answer. Now what is the way? Actually that should be away. So if I extend this vector like this, okay, now this, they both are away from the point. Now you will get this point, okay, and that will be your obtuse angle, and that is your acute angle. So remember this thing. So whenever you are going to use the scalar product to find the angle between two lines, ensure that their both points must be away from the point at which the angle is being measured. Okay. Find the angle between the vectors. So we have these two vectors and we want to find the angle between these two. The same method, strategy we have used, that we just find the dot product and we find the magnitudes, and then we get calculated and we got the angle. Now perpendicular vectors. If two vectors are perpendicular, so it means they are making an angle of 90 degree. So when they are making an angle of 90 degree, then the same formula we have discussed here, that cos theta is equal to A dot B is the magnitude of A times magnitude of B. Here the theta is 90 degree. So when theta is 90 degree, this cos 90 is equal to 0. And when this, we will multiply this here, what we get? A dot B equal to 0. So when we say that two vectors are perpendicular, then their scalar product must be equal to 0. Or you can think like that, whenever you have a question in your exam that proves that they are perpendicular, what will you do? You will find their scalar product and it must be equal to 0. Suppose we have shown that A and B are perpendicular, so what we will do? We'll do nothing but we'll find the dot product, and their dot product should be equal to 0. Look at this one. We have a question: A is equal to minus 2i plus 5j minus 4k, and B is equal to 4i minus 8j plus 5k. Find a vector which is perpendicular to both A and B. Find a vector which is perpendicular to both A and B. So what we do, that we start our question by supposing that we have this vector x, y, z, which is perpendicular to the vector A as well and the perpendicular to the vector B as well. So since this vector is perpendicular to both of them, so the dot product from this vector and dot product from this vector, they must be equal to 0. So what we do, we find the dot product, that is equal to 0. We get two equations. We have equation 1 and 2 here. When I solve them simultaneously, okay, so we got these three values of x, y, and z. So by placing this x, y, and z, you got this vector 7 upon 4i plus 3 upon 2j plus k. Now remember that you will encounter that type of problem in when you will solve the past paper, that you will solve the question and you will find this answer, and maybe in your mark scheme it will be written like that. So remember that when we have a vector answer with a fraction, we scale it. How to scale it? We scale like this. We have answered this one, 7 upon 4i plus 3 upon 2j plus k. It is not a standard to write a vector answer in a fraction form, okay, and we prefer to write in the whole number. So what we do, we just scale it. Here the denominator is 4, here the denominator is 2, and here is nothing, so I mean denominator is 1. So if I multiply the whole equation by 4, okay, if I multiply this whole vector by 4, right? So I will cancel it. So I will get 7i plus 3 times 4, 12 divided by 2, that is 6j plus 4k. So we scaled this one. So, but in fact, this vector and this vector, they both are same. There is not any difference between them. It is just a scaled form and it is a normal form. So either you write in this form or you write in this form, it is the same. Okay. Now, angle between two straight lines. We have done that how to find the angle but when we talk in terms of lines, before that we were talking only about the vectors, but when we talk in terms of lines, right? So what we do, that if you want to find the angle between two lines, you just do that, you find the angle between their direction vectors. Okay, no need to consider the whole line, we just take their direction vector and we use the same strategy, that d1 dot d2 divided by direction vector magnitude of first and the magnitude of second direction vector equals to cos theta. Okay, so be careful to find the angle between two lines, find the angle between their direction vector, and that will be the same, the angle between the given two lines. Now look at this question. The points A and B have position vectors this and this. The line L1 passes through the points A and B. Find the vector AB. We have two position vectors, so I can say this is my vector OA, this is my vector OB. Okay, I want to find the vector AB, so I can write AB equals to AO plus OB as you did in your AS. Okay, the same strategy here. So AO will be -2, -6, and +1, and OB will be 3, 4, 1. So what you will get, -2 plus 3, you will get 1, -6 plus 4, -2, and 1 plus 1, 2. So this is your vector AB. Okay. Find the vector equation of the line L1. Now I want to find the vector equation of the line L1. The L1 passes through both points A and B. We have done recently a previous one question like this. So we can take any of the initial point, either A or B. It's up to you. So I just take the initial point A here. So my point will be 2, 6, -1 plus, and this vector AB is, what is this? This is actually the distance between A and B. So I call it as, this is my direction vector. So I use it as a direction vector, 2, 6, -1 plus 3 times my 1, -2, 2. A second line L2 passes through the origin. Now this is the another line L2. It passed through the origin. Suppose this is the origin here. Okay, and is parallel to the vector I plus k. Again the same thing, it is parallel to this I plus k. So when they are parallel, what is the direction vector of this one? 1. There is no j, so I write 0. For k I write 1. So the direction vector of this line will be also 1, 0, 1. Okay, and the line L1 meets the line L2 at point C. Find the angle between line 1 and line 2. So as we have done here, to find the angle, no need to use the equation of the line, just use the direction vectors. Now, what was the direction vector of line L1? We use this AB as a direction vector. So there is one direction vector 1, -2, 2, and the other direction vector is 1, 0, 1. So these are two direction vector. I just find the scalar product between these and I get an angle. Now, so what we have done up till now, that we have found the equation of the straight line. We have seen that what is the equation of the straight line. What is the equation of the straight line in the vector form? That is r is equal to a plus lambda times b, where a is your position vector and b is your direction vector. Second thing what we have done here, that we learn about the scalar vectors, that what are the scalar vectors, and we use the scalar vectors to find the angle between two straight lines. Okay, and for finding the angle between straight lines, what we have done, There are two important points. The first thing, the lines you are using, they must be away from the point where we are measuring angle. The first thing. The second thing, that when you will find the angle between two lines, you will just use their direction vectors. Now, what we are going to do now, we want to find the point of intersection between two lines, as we did in our coordinate geometry. That what is the equation of point of intersection of two lines? So just take some recap that how we find the equation of the straight line, how we find the point of intersection. For example, we have 3x minus 2y is equal to 5, and we have 6x plus whatever y is equal to 10. If I want to find the intersection point, what we do? We just solve them simultaneously, and we find the value of x and value of y, and that is the intersection point. Now see how to do in vectors. The lines L1 and L2 have vector equations. R is equal to 3i plus j plus k plus lambda times this, and R is equal to this plus mu times this one respectively. Show that two lines intersect. First we have to show that they intersect, and then find the position vector of the point of intersection. Now, the very first thing, we have to show that these two lines intersect with each other. First point, that as I told you earlier, that whenever you have an equation, write this in a column vector form. So that will be 3 plus lambda, okay? Then that will be 1 minus 2 lambda, and that will be 1 minus k lambda. So I write in column vector form. Similarly, I can write the second vector in the same column form, minus 5 mu, minus 2 plus mu, 3 plus 4 mu. So I wrote these two vectors as a column vector. Now, we have to show that these two lines intersect. Now, what is the method in vector to show that two vectors are whether intersecting or not? What we do, if they are intersecting, then there must be some common point between these two lines. So what we do, the same strategy, we just equate them. We equate this column vector, the first line, the line L1, and this column vector, the second line L2, and we solve them simultaneously. We have three equations here, the first one, second one, and the third one. So there are two variables, so we need only two equations. So what we do, that we make three equations here. The first equation is 3 plus lambda is equal to minus 5 mu, and the second equation is 1 minus 2 lambda equals to minus 2 plus mu. So when I solve these two, since there are only two variables, so lambda is equal to 2 and mu is equal to minus 1. Now I want to show that these lines are intersecting. So if these lines are intersecting, if I place this value of lambda and mu in my third equation that I haven't used yet, I should get the same answer. Let's see. Now what I do, I just place this value 2 here, this value mu, negative 1, this value, I just displace negative 1 here, and when I place, I got the same answer. So it shows that the lines intersect. Okay. So now remember that whenever you have a question that you have to show that whether two lines are intersecting or not, what you have to do, you have two lines, you make two column vectors, just equate them, use any of the two equations and find the value of lambda and mu, and just place this one in the third equation that you haven't used, and if the answer is same, it means they are intersecting. If this answer is not same, it means they are not intersecting. Okay, so there are only three possibilities. First, whether the line will be parallel, either the line will be intersecting. In two dimension there are only two possibilities, but in three dimension we have one more third possibility. It is possible that two lines are not intersecting. We call them skew lines. If two lines are not intersecting, we call them skew line. And what are the skew lines? I will show you later a video about it, and you will see, because it is a three dimension, it is not a two possible to draw it here. So I will show you some video uh, in the next slide, and you will find out that how to what are the skew lines. Now we have proved that they are intersecting. Okay, now the second part is find the position vector of the point of intersection. Now it is easy, we have done that. They both are equal. We have found the value of lambda and mu. Just place this lambda and mu in any of this equation, either this one or of line L1 or line L2, and you will get the point, and this point is your point of intersection. Okay, look, watch this video here. We have a 3D object. This one is our 3D object. If I place a point here and I draw a line, you can see this line in blue. This is another point, another line, and you can see that these two lines are parallel. They are not intersecting. If I place another point line here, you can see that this line is neither intersecting with these any of these two lines. Okay, so this is called the skew line. When we work in 2D, we have only two options, that whether the line is parallel or not parallel. But when we work in 3D, we have another option here, that this line, you can see here, this line is not intersecting with either of these two lines. So we call that these lines are skew lines. We have seen that what are skew lines. Skew lines in three dimension are those lines which do not intersect with each other. Again, I am repeating, in three dimension there are three possibilities: whether lines are parallel, whether lines are skew, or whether lines are intersecting. So if these two lines are not intersecting, we call them skew lines. The line L1 has equation R is equal to this. The line L2 has the equation R is equal to this. Show that L1 and L2 do not meet. So when they do not meet, it means they are skew. The strategy is same. First, I will prefer that you make a column vector 1 plus lambda, 0 plus lambda, and minus 1. And you make 1 plus 2 mu, 3 plus mu, and 6 minus mu. Just equate them. So when I equate them, okay, and I got the value of lambda 6 and mu is equal to 3, and then I place this lambda 6 and mu 3 on the third one that I haven't used, and I got the equation minus 1 is not equal to 3. They are not equal, so they are not intersecting, and they are skew lines. Look at your exam question. The lines L and M have a vector equation here. R is equal to I plus j plus k plus S time I minus j plus 2k. R is equal to this one. So we have two equations here. Now again, this is your position vector of the first line. This is the direction vector. This is the position vector of the second line. This is the direction. Show that L and M intersect. We have to show that they are intersecting. So what will you do? So what we do, this is our first line. I make 1 plus s. For j, I again make 1 minus s. I am using these two. Okay. And for k, 1 plus 2k. Column vector for R1. Now we made the column vector of the second line. I call it R2. So that will be 4 plus 2t, 6 plus 2t, and 1 plus t. Now what will you do? You will just equate any of these two. Just like I equate 1 plus x is equal to 4 plus 2t. I equate 1 minus s is equal to 6 plus 2t. You will solve them simultaneously. You will get the value of s. You will get the value of t. When you will get these two values, you will just place it here, and by putting these two s and t, you should get the same answer Okay, and if the answer will be same, you will say that the both lines are intersecting. Now, calculate the acute angle between the lines. So, I told you to find the angle. You will just what will you do? You will just find the angle between their direction vectors. So, what are the direction vectors? The first direction vector is 1, -1 and 2. The second direction vector is 2, 2 and 2. So, first find the scalar product. So, that will be 2 plus -2 plus 4. So that will be 4. Now find the unit vector. So that will be 1 plus 1 plus 4. That will be 6. And again find the unit vector here. That will be square root 4 plus 4 plus 4. So that will be 12. Okay. So we have the formula A dot B divided by magnitude of A, magnitude of B, that is equal to cos theta, and you will find the value of theta. There is one more question here. The same strategy, the line L and M have the equations. R is equal to this one and R is equal to this. Show that L and M intersect, and show that given that L and M intersect, show that 2A minus B is equal to 4. The same strategy, you will make a column vector of this one, column vector of this one, equate any two, and you will get this equation. Given also that L and M are perpendicular, when they are perpendicular, A dot B must be equal to 0. Just take the direction vector of this line, direction vector of this line, and it must be 0, and find the value of A and B. Similarly, when A and B have these values, find the position vector of the point of intersection. Now, we have shortest distance. Shortest or perpendicular distance between parallel line. Shortest distance is always a perpendicular distance. We have discussed in ALevels and AS as well that shortest distance are the perpendicular distance, or in other words you can say the perpendicular distance are shortest distances. Okay. Now we have to show that the shortest distance between these two parallel lines, show that the shortest distance between the parallel line with the equation this and this is this one. We want to prove this one. Now actually what is the idea behind it? The idea is that we say that these are the two parallel lines and we want to find the shortest distance between two. Shortest distance is a perpendicular distance. So when they are two parallel lines, so it is necessary it make a right angle with any one of the line. It will make a right angle. It is necessary. So what is the idea here? That we get some vector, column vector for this AB. If I got the column vector of AB, then this line and this L2 or L1, they must be perpendicular to each other. And what we have done, for perpendicular, their dot product must be equal to 0. Okay, let's see how will we do that. This is the idea behind. Now what we do, we have this point A and we have this point B here. So point A passing through L1, we have just supposed this one, and point B passing through L2. So what is the equation of L1? This one, if I write in this form, this is our vector OA. This will work as our vector OA. So our vector OA will be, here will be 1 plus 5 lambda, 2 plus 4 lambda, and minus 1 plus 3 times lambda. So this will work as our point A. This is our generic point. Now for point B, we can use this equation, that is 2 plus 5 mu, and here j is 0, 0 plus 4 times mu, and 1 plus 3 times mu. So this will work as our point B. Okay. And now we want to vector find a vector for the point for line AB. So AB will be AO plus OB. Now this is our OA vector. This is our OB vector. Now what will I do? I will just add them, or you can write the same thing like this, that will be OB minus OA. Okay, so this is your OB and this is your OA, and you will get a vector for AB. Now this is our vector AB. Okay, we have replaced here, there will be some lambda minus mu, so I have introduced a new variable t here to just to avoid some confusions. Now we say that they are perpendicular. So when they are perpendicular, their dot product must be equal to 0. So what I do, so I take this vector and I take the direction vector of any of the lines. Since they are parallel, their direction vector is same. So this vector dot 543, this must be equal to 0. So when I solve this one, I got the value of t. And if I place this value of t here, what will I get? I will get the point, I will get the line AB. Okay, so I get the column vector for this line AB. But we need the shortest distance. So what we do, we find the magnitude of this. And what is the magnitude? That is the x square plus y square plus z square. So you got the magnitude. So remember that when we have to work for the perpendicular distance between two parallel lines or shortest distance between two parallel lines, we use two equations. With the help of these two equations, we make a new equation, and that will work as a column vector for the line AB, or you can say that will work as a direction vector for AB. So this AB is in fact our direction vector. Now the important thing is here that when you will subtract these two, you will get lambda and mu, two variable. Now to avoid these two, just take a column common of this from the whole equation and replace it by t, so that you will reduce your variables here. Okay, and then you can easily find out the value of t, or in other words, if you are not using that, you will find the value of mu minus lambda, and again the same strategy is here. Okay? Now the perpendicular distance between any two lines which are not parallel. Okay, now the same question we have here now, the similar question that L1 and L2 have the equation r is equal to this and r is equal to this. Two lines are there. Now you can see here that its direction vector is 0, 1, 1. Its direction is 2, minus 1, 1. So they are not parallel lines. They are not parallel. So we don't know that whether they are perpendicular or not, but they are not parallel. Find the shortest distance between these two lines. Now there is a slight change. When two lines are parallel, there is only one line making perpendicular with this distance line AB. But here they both will make a perpendicular line. Now you can see here, if they are not intersect, they are not parallel lines. So if I take a point A here, a point B here, this line will definitely, that is the shortest distance, so it will make a right angle with both of the lines A and B. Okay, now the strategy is same as we have done before. So we have the position vector of A, that is the first line L1. So 1 plus lambda times 0, 0 plus lambda, so we have this position vector. Similarly, by these two I get the position vector of B. I find this line AB, the OB minus OA. Okay, and I got this vector. Now this vector is perpendicular to A and B both. Okay, so it means, what was the direction vector of this one? That was the 0, 1, 1. And what was the direction vector of this line? That was 2, minus 1, 1. This is the direction vector of the second line. So it means that this direction vector of this line AB is perpendicular to this also and is perpendicular to this one as well. So when I will take the dot product, when I will take the dot product of AB with this 0 dot 1, that must be equal to 0. So I get one equation, lambda plus mu equals to 1. Similarly, dot product of this AB with the other equation, that with the other direction vector 2 minus 1 1. 2 minus 1 1. Then I will get another equation, lambda plus 3 mu equals to 3. You will do the same strategy here, that minus 2 plus 2 mu and 3 minus mu and minus 1 minus mu dot 2 minus 1 equals to 0. And when you will solve it, you will get this. Now we have these two equations. This is our first equation and this is our second equation. When I will solve them simultaneously, I will get the value of lambda and mu. And this lambda and mu, if you will place in your direction vector of AB, you will get this vector 0, 2, minus 2. And since we want to find the shortest distance, so the magnitude of this vector 0, 2, minus 2 is the shortest distance between these two perpendicular lines. Okay. So we have done that, how to find the perpendicular distance between two parallel lines, and also we have done that how to find the perpendicular distance between two non-parallel lines. Now look at this question. The question says the point P has coordinate -1, 4, 11. This is our point P here. Okay, what are the coordinates? -4, 11. First, your general knowledge, since it is a point P, I can write it as a position vector, OP, 1, -4, 11. Okay, there is a line L has an equation R is equal to this. We have this line here, right? And if I write it in this form, 1 plus 2 lambda, 3 plus lambda, and -4 plus 3 lambda. Now the question is, find the perpendicular distance from point P to the line L. So I want to find this perpendicular distance. Now tell me, how can you find the perpendicular distance? Now let's suppose if that this point is Q here, so this will work as our position vector OQ. This is our OP. Can you find the PQ? So what will be PQ? PQ will be OQ minus OP. This is your OQ, this is your OP. When you will subtract them, you will get a vector PQ. Okay, and then when you will get the value of PQ, this will be your vector PQ, and this is perpendicular to this line. So what is the direction vector of this line? That is 2, 1, 3. So whatever vector you find this PQ here, you will say that this PQ dot 2, 1, 3 will equal to 0. When you make it 0, there is only one variable here. You will find the value of lambda. And when you will find the value of lambda, you will place it here in this PQ equation. This PQ, you will find the vector PQ. And when you will find the vector PQ, you will find the magnitude. And this magnitude will be the shortest distance. Right? There is one more question. You can see that with respect to the origin O, the point A, B, and C, a position vector given by OA, OB, and OC. The midpoint of AB is N. The point N lies on. Yes, this is a similar question as you have encountered in your AS as well. There were so many questions like this in your AS. Find the vector application of the line Mn. It is given that Mn intersects BC at point P. Find the position vector of P. So you have to solve them simultaneously. It is a question of simultaneous equation. The first is the same that you have done in your AS. The first one is we want to find the vector equation of the line Mn. So for finding the vector equation of the line Mn, you need R is equal to A plus lambda times B. So first you need initial point. or you can say you want some position vector, and this is your direction vector. Okay, so since it is a mn, so your position vector or maybe any of the OM you can use, or you can use ON. You can use any of the, and what will be the direction vector? Direction vector will be your MN vector. That will be actually your direction vector. So now our task is how to find OM and ON. Now if you'll see this question, the midpoint of AB is M. Okay, so this is our OA, this is our OB. So if I make a line, this is a point A here, this is a point B here, and the midpoint is M here. So it means if you find AB, that is AO plus OB. Okay, so this is your OA, you can write as AO, and this is your OB. And if you will half of it, what will you get? AM. This will be your AM vector. When you will find AB, when you will make it half, then it is a midpoint. Okay, then there you will get AM vector. Now, what will be your OM? Your OM will be OA plus AM. Now, this is your OA, this is your AM, you will get the vector OM, that will become your position vector, right? Similarly, you will work for N. The point N lies on AC between A and C such that AN is equal to 2 times NC. Now look like this. This is a point A here. This is a point C here. And this N lies between A and C. And such that the ratio between AN and NC, AN equals to 2 times NC. So I can say AN upon NC will be 2:1. So it means if it is 2, that will be 1. So it means, in other words, you can say there is a ratio of 2, 1. So that is 2/3 and this is 1/3. So AN will be 2/3 of, this is 2/3 of which line? AC. So this is 2/3 of AC. Now, this we have OA, we have OC, we can find AC. So by multiplying by 2 by 3, we will get the vector AN. And what we need the vector ON. So ON will become OA plus AN, right? OA is given to you and you will calculate from there, and then you will get the vector ON. This is your OM, this is your ON. You can take any of the point as a starting point. Okay, and when you will subtract them, you will get the direction vector, that is Mn, and you will make a equation R is equal to A plus lambda times B. Now it is given that Mn intersects BC. Now you have the equation of vector equation of Mn intersects BC. You can make the equation of BC. This can be your starting point, and by subtracting them you can find the direction vector. So this will be the equation of BC, and then you have to show the intersection, and we have done before that for intersection we just make two column vector, we equate them, we solve simultaneously any two of the equations, and we put in the third one and we find the intersection point, right? So there is one more question, the very similar question like this, you can try it. Okay, and now you can see that what our syllabus is. So our first part was use standard notations, and you have done it in your AS. So no need to, just we have used all these things. Carry out addition and subtraction of vectors, you know very well. Multiplication of vector by a scalar. Interpret this operation in geometrical term. The scalar means when we multiply the vector by scalar, they are the parallel vectors. Addition of the vectors, we know that when we have this vector, if we have this OA and we have another vector OB, right? So if this is the origin O here, this is OA, this is our OB. So what will be the AB? I can make a parallelogram, and this one will be your diagonal vector. Similarly, if I am subtracting, If I say this is OA, this is our OB. Now if I am subtracting them, right? So this is your OA vector, this is your OB vector. So this will be just similar to OA. Okay. Again, we have the parallelogram law. If you will sub this OA, AO plus OB will give you this diagonal vector. When you will subtract them, it will give you another diagonal vector. Calculate the magnitude of the vector. You know that how to find the magnitude, that is x square plus y square plus z square. Unit vector is vector divided by its magnitude. Sorry, no magnitude here. Vector divided by its magnitude. This is the unit vector. You know the displacement vector. Yes, they are the direction vector we have done here. They are the displacement vectors. Position vector, the vector which start from the origin, they are the position vector. And what we have done today, understand the significance of all the symbols used when the equation of the straight line is expressed in the form r is equal to a plus tb. Find the equation of the line. Determine whether two lines are parallel, intersect, or skew. We have seen how to determine that the lines are parallel, direction vector is same. When the lines are intersecting, we will equate them. We will solve two equations. Put in third, it must be same. And if it is not same, they are skew. Find the point of the intersection. We have done this. To formulate the calculate the scalar product of two vectors. Scalar product in problems involving lines and vectors. Okay. In this, it is given that we should know shortest distance between two skew lines. Not required. We haven't done. Finding the equation of the common perpendicular to skew line. We have not done. We have just seen how to find the shortest distance between parallel lines and not parallel lines. But we have not discussed about the skew lines. Finding the angle between two lines. Yes, you have seen how to find the angle between them. Find the foot of the perpendicular from point to the line equation may involve. Yeah, we have seen the last question that how to find the equation from finding the perpendicular distance from line to a point. Okay, and it can come into the cuboids, as you have seen some questions in your AS also, that when you have these 3D problems and you find the angle between them, similarly you can do that. So that was all about the vector topic. So since for you A2 students, this is a new to the syllabus, and you will not find the past papers sums uh, for this topic. However, I would recommend that you can use your textbook, okay, and you can do some practice from the textbook. Also, what 5 or 6 questions I have discussed here, that is, these are also the past paper question. You can try these one, and still, if you have any problem, you can contact me. Thank you very much. Allah Hafiz.